Okay, so now let's consider a scenario where in the functional component we are doing some expensive computation on each render. An example of that can be, let's say we have a function. That function can be simply, let's say, power function. I can have a more expensive thing, but right now I'm just taking that, let's say some number n is passed, and then just you return, let's say, I don't know, like 2 raised to the power n you're returning. So it can be any expensive thing. I'm just taking a simple example where it is not that expensive but still somewhat expensive, which means that given a number, let's say 15 is given, then 2 raised to the power 15 you have to calculate. Okay, and it could be like very much intensive computation also, but right now let's take this. So how the number is passed, let's say this number is passed directly as a prop, which means that in the greeting you are passing some number n is equal to, let's say, 15. Okay, and that 15 number is available in props.n, and then I can create something. So let's say const value is equal to power of props.n. So I have the value. Now just render it. So let's have a simple div where I have a value, and that value is value. So this should be enough, right? So now you can see that 2 raised to the power 15 thing is printed here. So whatever value is passed from here, that value is printed. Now you can imagine that this is like some expensive calculation. This is expensive. Okay, now the point is that I wanted to show you that since this is expensive, you want to minimize the number of times this function is called. Okay, which means that in general, if for the same value, if the props.n is same, then you don't want to call it again and again and again, right? But the problem is that, yeah, right now initially for the first render definitely that thing will be called, otherwise how to get the value? So you will pass that with the corresponding props.n and you will get that value. But the problem is that after that, let's say I'm clicking on this change name. What this change name is doing? Change name is a button where you click, then the other prop, so this name prop is changing. Now you'll see that my n prop is not changing, my name prop is changing. Okay, but even if I change the name prop, which means Alex becomes Bob, but then also you can see that this expensive calculation is keeps on doing. That is not I want. This value is not changing every time the expensive computation is happening, and it is giving us the same answer. But why to call that again and again to get the same answer? I know that nothing has changed, so why not have a mechanism where I should cache the value? The caching is also called sometimes memoization. So essentially memoization or caching is a way to save the value, so that for the same data I don't need to compute again and again, and later if the data is changing, then only I'm calling this again. That is what my requirement is there. Right now what you can do is that you can use something called useMemo. So useMemo, this is a hook given by React, where what you can do is that you can pass a function, and the return value of that function will be provided to this value. And you can see that this is giving us a warning because it is saying that you should pass dependency array. In fact, like useEffect, useMemo also has a dependency array, right? And if you simply cache it, if you simply pass empty array, then it will be just called once. But actually you don't want to pass empty array, right? You want to pass props.n, because whenever that thing is changing, then you want to update its value. Okay, so now you will see that, so essentially just to highlight what is happening, whenever this function is rendering, then it sees that whether props.n is changing or not. Okay, so first time obviously this whole thing will be calculated, but from the second time onwards it will check that whether my props.n is changing or not. If props.n is not changing, for example name is changing, this props.name is changing, then it will not recompute this value. It will just, whatever the earlier value is there, it will remain that, and I will not call this power function again, because it will not be this function will not be called. If this is changing, then this function will be called again, and whatever the return value of this function is there, that will be again cached in this value, which means that again in the next render, again if props.n is not changing, the same value will be used. Remember that you are not caching this function, you are caching the output of this function, which means that what React will do, that in every render, if something is not if let's say this thing is changing, whenever this thing is changing, then React will call this function, and whatever is the return value of that function, that is cached. Okay, this function is not cached, functions called when I call that function, whatever is the value, that thing is called. Okay, so now you can see that the behavior will be same, so the answer will be same, and this expensive calculation is done for the first time. But after that, when you keep on changing the name, that expensive calculation is no more done. Why? Because React is seeing that, yeah, you know what, props.name is changing, but props.n is not changing, so why should I bother to compute it again? So the cached value, the stored value, the memoized value of this function called answer, already returned answer, that is cached, and that will only change when props.n will change. In fact, you can prove that by having a second button. So let's say in a similar manner I have some second button, and in this case I change n. Okay, and when I change n, then here so what to do, let's have a variable, let's say const num comma set num is equal to use state, and in the use state let's say yeah, so let's say it is 15, and rather than passing 15 I'll pass num here, that is fine, and set num I will use whenever you want to change num, and I'll, let's say, change that num by 1 every time, so that 15 will become 16, 17, whatever. Okay, so the point is that whenever the n will change, then this num will change, which means that the past value will change. Okay, and then this expensive computation should be redone, because that is what I want. But if the name is changing, then it should not be. So right now the first time expensive calculation is done. Whenever I change name, expensive computation is not done. But when I change n, so from 15 I make it 16, then you can see that now 2 raised to 16 is again is given here, because now cache is invalidated. Why? Because since the value is changing, I have to do the expensive calculation again. Okay, so again, whenever name is changing, nothing is happening, but whenever n is changing, then the expensive computation is done. So that is what is being done here. Now just to show you that why dependency array is important, if you remove this, then this will not be computed whenever props.n is changing. This will just be computed on first mount. After that it will never be computed again, right? And that's why it is giving you a little warning, so that it is suggesting you that you should write props.n. Let me show you what is happening. If you don't write there, then when you change name, then obviously things are not changing, this value is not changing. But let's say now you change n. Even if you change n, which means that my n is changing. In fact, you can prove that by printing props.n here. Okay, so props.n. Okay, you can see that my n was 15. This expensive calculation was done on 15. That is fine. Whenever my name is changing, then it is remaining on 15, and that's why it is expensive computation is not done. That is fine. But if you change n, then it is becoming 16. Then also this value is not changing. 17, then also this value is not changing, because this is cached and this thing is not changing. Why this is not changing? Because we told it not to change. We told it just cache it on mount and after that never change it, right? That's why we have to pass props.n here, and that is how the caching works. Okay, so now it will work as expected. Okay, so on name change nothing will happen. On n change this will keep on doing expensive computation. Yeah, so a couple of more things. We saw that like use effect, if this is empty array, then this will only be run at the mount. Okay, it will not run whenever the props.n is changing. That's what we saw. Similarly, like use effect, if we remove this dependency array altogether, then yeah, this is saying that you should give dependency array. But let's say even if they are suggesting a warning, but that is fine. Let's say we don't pass dependency array, then again the behavior will be like use effect. In use effect, if you don't pass dependency array, and then what was the behavior? The behavior was that use effect will run on every re-render again and again, and we can see that here also, that first time it is that expensive calculation is done, but after that even if I'm changing name, then also that expensive computation is done, right? So it runs again and again, and then you might understand that if it is running again and again, then there is no point of doing memoization at all, which means that this is like now completely equivalent to like this. Okay, directly like this. So why to use memo? Okay, so but that's what I wanted to say, that if you use memo and you don't pass dependency array, then this is as good as the second line. Okay, so never do that. Always pass some dependency array, and more preferably always pass all the values which it depends on. And remember that the actual memoization is happening of the return value of this function, not this one. So you remember, you might be into the habit of thinking that yeah, inside callback function whatever I'm writing, that is not running, right? That is not running, because in use effect that is how it works. In use effect, whatever you write inside the callback function, that is not running at the time of render. It is running after, that effect is running after the render has happened. That is not the case here. Here whatever you are writing inside this function, this thing is running while the render. You can clearly see that even in the first render, expensive thing is printing, which means that this function is rather called in the render itself. Okay, so you have to be careful that whatever you think that you cannot write inside render, you should not write here also. So for example, generally things like updating of any reference variable. So any reference variable dot current. So using useref you have got something, and dot current. Generally those things you should never modify inside the render function directly here, right? So similarly those things you never do here also, because whatever is written here, you assume that is written here directly. It is just that it is being cached, nothing else. Okay, apart from that, one more thing is that this memoization what we are doing, it is sort of a optimization thing given to us by React, but this is not a guarantee. What do I mean by guarantee? Which means that yeah, I gave something like this, that you know what, till my props.n is not changing, please cache this value. So you can see that right now whatever the value was 15, yeah, that is fine. And we can see that whenever I am clicking next, then you can see that yeah, this is cached. Okay, but just remember that it is not the every time I'm rendering this, and I'm not recomputing this. React is just taking this value from the cache, but that is not a guarantee. Which means that even if let's say you have not changed props.n, then also React might forget this value intentionally, and then it might call it again. So this might be a subtle thing, but you should just understand that this is generally cached, generally remembered by React, but React can choose to forget it. And why it might choose to forget it? Because of a number of reasons. Maybe that in this computer there is some memory issue is there, like some shortage of memory is there. So React is not able to get too much memory. So let's say some big thing is stored, then and React does not know that whether it will be used later in some time or not. So React forgets that, and later if you change the name and it renders it again, then that time even if props.name was changing, not n, but then also since React forgot this value, it might compute it again. So that's what I'm trying to say, that this is just a sort of intent given to React. This is not a guarantee that I have used useMemo, then how dare you call this again, right? I told you to remember, you have to remember it. That's why you have to understand that it is not like that. React might choose to forget it. So you should not make any assumptions about that React must use some cached value. Okay, so that is just a subtlety, but that is how internally it works. Okay, so that is how generally useMemo works in React.
And the example which we are taking here, it took just one value in the dependency array, but in general it can be anything. So for example, let's say rather than n, let's say it has n and m two values, and you return something, a function of n and m both. Then let's say here also some other value you are passing, then that value will also be in the dependency array. In general, this value can come again from props or state anywhere. So you can understand that dependency array will be in general a function of whatever the variables the cached value depends on. Okay, in other extreme can be that, let's say there is no value it is depending on. So let's say this thing is some 20, which is a constant, right? Then there is no value, external value, which it depends on. So in that case it will be normally just like whatever the expensive computation that is just on done on 20. Okay, so it will be something like this. However, the point to note here is that in this case we can see that the computation is done on the first render. We can see that the computation is done on the first render. What if you don't want that? What if you want that, let's say after some time I try to use this value, and then only whenever I'm trying to use this value for the first time, then only this computation should be done. That is called lazy evaluation of a value. But then the caching will be done once the first evaluation is done. But the first evaluation is not on the first render. Let's say it can be in a use effect, it can be on some handle click event handler of some button or something. For example, let's say initially there is a button, and when we click on that button, then we evaluate. So something like this. And when I click on this button, then the actual evaluation should happen. So how to do that? So for that, what we can do, that we can have a ref value, which will essentially be an instance variable sort of thing for functional component, and there we can store that thing. Okay, so let's say value is equal to use ref null. Let's say the value starts with null, but after some time I do the evaluation, and that evaluation will be something like, let's say, get cached value, or let's say simply value. When I call this, then you get the actual value, and now here you want to return this. Right now you can see it is not cached, but I'll just now show you that how it can be evaluated. So right now let's say something like this. So what we're going to do is that once you get the value, once you click, then essentially let's say you are going to set this into some reference. So for example, you get this thing, but when you click, then whatever the value you are getting, that value you can assign it to something. So for example, we can set the value, or better, let's say that this value is set in some other reference. So let's say, so simply const data is equal to, or it can be a state variable also, but right now let's just take another reference, and initially it will be undefined. So it will be something like, let's say, data dot current is equal to this thing. And so yeah, so we need to re-render also it, right? So whenever I click, then the new data, with new data, it should re-render, right? So better to take it a state variable. So let's say data use state, and let's say that initially it is undefined, that is fine, but as soon as I get that value, I should set that data. And how to set that data? That data I am setting here. So what is happening when I am clicking, then the value is evaluated, and then whatever the value which we get from this function, that is set into this thing, and that data can be printed here. So this is essentially the value. Yeah, so right now you can see that this value we are not using, but anyways we are going to use that soon. Right now just wanted to show you that let's see, if you run this, then initially this value, this data thing was undefined, and that's why you can see that nothing is printed here. But as soon as you click on evaluate, then this data is coming, because when I click on evaluate, then I'm setting this data to get value. So, and what is return, get value returning? Get value is returning this thing part 20. But this is an expensive calculation, and we can see that whenever I'm clicking again and again, every time that expensive calculation is being done, that I don't want. And exactly for that only, earlier I defined that value thing as a ref. What we are going to do is that we are going to do something like val this dot current. We are going to check that whether this thing is currently set or not. So if this thing is currently null, that will mean that we need to evaluate this, and this needs to be evaluated to power 20, and you can see that this power 20 can be written here, which means that whatever the computation you want to do, whether it depends on when some variable or some constant, doesn't matter. But now you can see that when earlier this thing power 20 was not evaluated, but the first time when this is used, then this is returning a value which is power 20, because initially it will be null, and that point of time it will be returning power 20, which means that it will be computing the power 20 for the first time. Second time when I click again, in this expensive computation, which means that power 20 will not be called, because I already have that data in this thing, and which means that this thing will not be null, this thing will be something, and directly that value will be returned. So right now you can see that when I refresh, then initially this thing is undefined, that is fine. When I click, then I do expensive calculation and get that data. But after that, does not matter how many times I click, or does not matter how many times the props change, this expensive computation will not be done, because it is cached, right? So this is an example of using caching something without using useMemo, but generally this sort of pattern applies when you need to do the computation of data which is final, which is only for the constant data, and then it does not change later. And if you do using useMemo, then it will be done at the first render, but if you use this pattern, then it will be done at the first time while you are using. This is called lazy evaluation. So now let's get back to our useMemo example. So we were earlier using useMemo, and there we had this let's say power function. Okay, so that is fine. The point is that this useMemo, inside this useMemo, whatever we are using, this can be anything. It can be any value. It can be in fact a function also. It can be a particular let's say some react element also, which means that let's say some component is there which is like expensive to render. So for example, let's say there is some component is there, and this component is, let's say, somewhat expensive to render. Okay, then we can very well do the same thing here also. So let's say some number is passed to this, and then let's say props dot n is getting passed. Then you can specify props dot n, and then in this case the component which is going to be rendered from here, this component will be cached. Okay, so whenever props dot n is changing, then only this component, and this value is essentially a component now. Component, it's not a component, essentially it's a react element. Okay, so this whatever, let's say this, let's call it child, then this you can use here, and then this child will be cached. Okay, this element essentially is cached, and whenever props dot n is changing, then only it is created again. So in that sort of optimizations for any sort of value which you want to cache, that you can do using useMemo. In fact, let me give you an example. You can also create some sort of caching for functions also. So which means that this can be a proper some function also. So let's say you have this function. Okay, and this function is defined inside the component, inside the functional component. And now let's say this function you are using somewhere. Let's say you are clicking on some element. So right now it can be something like that. Let's say you have a button, and when you click on that button, then on click you are calling this, let's say. So let's say you are calling this with something. So let's say power of 10 you are calling, and this let's say this value you are setting in that data variable. So something like this. So essentially what you are doing, when you are clicking, then power 10 is calculated, and that power 10, whatever the answer is there, that is given, provided to set data, which means that now my data is going to be that thing, power of 10. So whatever this thing returns, that is going to be rendered here. So now we are not using useMemo for now. We will use this after some time, but right now we are not using. So you can see that when I click, then 2 raised to the power 10 is calculated, and it is that expensive computation is done. And obviously this is like this computation is done every time. So whenever you click, then this is being done. That is fine. The more important thing here is that you can understand that this function is created every time. So whenever and again, this can be like something like, let's say you don't provide any argument to it, and that argument is, let's say here, either hard coded, or you are using, let's say, props dot n. Okay, that also you can do. So now props dot n, which is getting passed, is what is 15, right? So here props dot n is going to be 15, and then when I click, then that 2 raised to the power 15 is computed and entered here. But the main point is that this function is being created every time, which means that every time the rendering is happening, this function is created every time. Now this function is right now just a one liner, but you can understand that there can be 20 lines of code, and which can be computationally intensive also, right? Okay, so why to create a function again and again and again on each render? Okay, so in order to optimize for that, we have, so and again this can be an arrow function, it can be a normal function, anything it can be there, right? So in order to optimize for that, what we can do, so let's firstly convert it to arrow function, though you don't need to, but I'm just showing you by an example that let's say this is a arrow function, and then you understand that every time I click, then this computation is happening, that is fine, but every time I am rendering, this function is created again, which means that every time it is rendering, this power function is a new function altogether. Let's say I don't want that, I want to cache this value. Now we know that we can use useMemo also for any sort of value, but and I'll show you after some time using useMemo also how you can cache the thing, but caching of functions is a common use case, and for that we have a special hook in React which is called useCallback, which means that instead of directly writing that, if I use callback, then inside that I can pass it like that, and again here also there is a dependency array, and in that dependency array you need to pass whatever it depends on. So it depends on props.n. Okay, so we can clearly see that now this function is not created every time. First time when it is rendered, then it is created, and after that whenever the dependency array value is changing, so whenever you are passing a different value here, then only this thing is computed again, otherwise it's a cached value. So just on the face of it, just looking on it, you will think that there is no difference, but actually the difference is there in terms of memory consumption. So every time you are creating this thing is rendering, this thing is not creating a new power function, rather this power function is cached. Okay, so this use callback can be used for that purpose. However, in fact we know that useMemo can do anything, right? So useMemo can do anything, which means that it can cache anything. So if you use useMemo, then also you can exactly achieve the same thing using something like this. So the same thing I can do, something like this power, and now this power function is cached using useMemo rather than use callback. So use memo, and inside that, what is the thing? Inside this, the syntax is that there is a function, and whatever this function returns, that thing is cached, right? So here I have to essentially do something like this, so you can understand. Okay, so you can see that right now I will provide a dependency array, and here props.n will be passed, but now you see the difference. The here double arrow is there. Why? Because that is the syntax of useMemo. useMemo is a function, and that function returns whatever. So here whatever something I read. So earlier we used something like this, like, okay, so whatever the value is returned from this function, that is cached. Similarly, this first arrow function is there, this is returning this function. So whatever is returned from useMemo from the first function, that is cached. In this case, the outer function, the first function is returning another function, so that function is cached, and you can see that the behavior will be exactly the same. When I click, then I get whatever the thing. So in this case also, my this function is cached, and whenever props.n is changing, then only this function is recreated, otherwise this function is cached, and every time that cached function is used rather than creating that function again and again. But now you can understand that this syntax is somewhat tedious, right? So it's like function which is returning again a function, so you can do like this also. However, for simplicity, React has provided another API which is in form of a hook, where use callback is a shortcut, is a shortcut for exactly the same thing, but it provides a slightly easier syntax. Other than that, both are exactly same. So in essence, what is happening is that if you are using something like, let's say, use callback and some function is there, and then some dependency array is there, whatever dependency array is there, right? Now this thing is just a this thing is just equivalent to using useMemo, but we know that useMemo has to have a function, and that must return a function if we want to cache it, right? So you can understand that whatever dependency array that will be same, but if our return value is a function, then rather than using this thing where return value is a function, you can directly pass that function as the first argument itself and with the same dependency array. So these two are completely, here also you can see the same thing. Here this function is passed as the first argument, but in useMemo case there is a function which returns that function. Okay, so just this thing is just a shortcut for that. Okay, so now you have understood that what is useMemo and what is useCallback. useMemo is used to memoize or cache any sort of value which can be function itself. However, for functions, useCallback is another shortcut where useCallback is used to memoize or cache functions only. Okay, so this is all we need to know about use callback and useMemo. So that will be all for this video. Thanks a lot.